Hello students. So in our previous class we have learned about evaporation. Yes. So now we will be looking at the factors affecting evaporation. Okay. So the first factor that is affecting evaporation is the surface area. Okay. And how it affects the how surface area affects evaporation? It affects the rate of evaporation. So what is rate of evaporation? So rate of evaporation means that how quickly any liquid will evaporate. That is known as its rate of evaporation. Okay. So rate means in simple word we can say speed of evaporation. Okay. So the first factor is surface area. Okay. And how it affects? It affects the rate of evaporation increases when surface area increases. Okay. So what is surface area? So the area of the surface. Okay. So area of any surface is known as surface area. So what is surface? The surface is the topmost layer or topmost part of any metal. Okay. Suppose this is a table, and we say what is the surface of this table? This particular thing is known as the surface. Okay. So the topmost layer of anything is known as the surface. Okay. Clear? So its area, the area of the surface is known as surface area. Okay. So how it will affect the rate of evaporation? How it will increase? It will increase because we know that evaporation takes place because the particles, particles of any matter that is present at the surface has higher energy or higher kinetic energy than the particles below the surface. Okay. So the particles in the surface, they have higher kinetic energy than the particles below the surface of any liquid. Okay. So what it means, whenever they have enough energy and more energy than their force of attraction between the particles, they can easily move away. Okay. Move from their definite position and they will turn into gas. Okay. That means the particles that are present at the surface of any liquid, they have higher kinetic energy. So whenever their energy is more than the force of attraction between the particles of the liquid, they turn into gases. Okay. And only due to this, this liquid can evaporate below, that is, they can change into their gaseous form below their boiling point. Okay. So that means if the liquid has more number of particles in their surface, it will evaporate more quickly. Yes. So if any liquid will have more number of particles on the surface, then that liquid, okay, if any liquid, suppose we have a liquid, so it depends on the number of particles that is present on the surface. If the number of particles present in the surface is more, this liquid will evaporate faster. Okay. So now what happens, if the surface area, suppose here we are taking a smaller plate, here we are taking a bigger plate. Okay. In both this plate we are giving water. This blue thing is, I am drawing a water. Okay. So suppose this is water. Okay. So now since here the surface is smaller, so what will happen? The number of particles in the surface will also be less. Okay. Since here the surface is bigger, so the number of particles of water on the surface will be more. Okay. So if number of particles in the surface will be more, then the number of particles with higher energy will be also more, because the particles which are present on the surface will have higher energy. So if at the surface, if it will, we will have more number of particles, then the particles with higher energy will also increase. So therefore this in the surface, where the surface in on the plate where the surface is large, that is on the larger plate where the surface is larger, what will happen? The number of particles at the surface will be more. Okay. So these particles at the surface will have higher energy, so they will evaporate easily. Okay. So if when we will keep them in, suppose in sunlight, okay, what will happen? So more number of particles will get the energy from the sunlight. Okay. So they can easily evaporate. Yes. Yes. So therefore what you will see? You will see that generally, suppose what we drink tea in our house. Okay. So generally if tea is hot, okay, so what it is done? Generally in the older days in villages still, you can see that some people, they pour the tea on the plates. Okay. So that it what cools easily. Okay. Why it cools easily? Because on when we pour the tea on the plate, the surface increases. Okay. So therefore the number of particles on the surface will be also more, since the surface increases. So number of particles on the surface will be also more. Okay. So when the number of particles on the surface will be more, it can easily evaporate, and once the particles at the top will evaporate, it will gain the energy from the particles below it. So as a whole, once a small portion of the particle will evaporate and the other portion of the particle, it will be polar. Okay, so it will lose energy. So that is we will learn more about this on the cooling effect of evaporation. Okay, so this is the first factor, that is when surface area increases, the rate of evaporation increases. Okay, so next we will be looking at the second factor, that is temperature. Okay, so the second factor is temperature. So what happens, we also have similar effect with the increase of temperature, that is when temperature increases, the rate of evaporation increases. Okay, so why it is so? So we know that when you heat any object, when you heat any metal, what we know, that the energy of the particle increases. That we know. Yes, that also we have seen while heating any solid into liquid. What we see, that we are heating the solid, and when you heat the solid, the energy of the particle increases and it changes into liquid. Okay, so similar thing will happen in case of liquid. So when you will heat any liquid, the energy of the particle will increase. Okay, so what will happen? So evaporation is related to the energy of the particle at the surface. Okay, so when you will increase the temperature, that is when you will heat it, okay, when the temperature will be higher, then what will happen? Energy will increase of the particle. The particles will have higher energy. So when temperature will be more, what will happen? More number of particles will have higher energy. That is, more number of particles will have energy that is higher than the force of attraction between them. Okay, so when this particle can move to the gaseous state, when any particle will move to the gaseous state, when the particles will have energy higher than the force of attraction between the particles. Okay, so if the temperature will be more, so what will happen? The particles, more number of particles. Okay, suppose if temperature is lower, if two particles have higher energy, when temperature will be more, 4, 5, 6, so more number of particles will have higher energy than the force of attraction between the particles of the liquid. So what will happen? More number of particles will evaporate. Okay, so what will happen? The liquid will evaporate faster. Okay, so that is when temperature increases, then rate of evaporation increases. Why? Because when temperature increases, then more number of particles will gain higher energy. Okay, and when more number of particles will gain higher energy, the whole liquid will evaporate faster. Okay, so the next factor is humidity. Okay, so the next factor is humidity. So what is humidity? Humidity is very simple. Okay, so generally the terms humidity seems to be something unique, but it is very simple. Everyone of us know about it. That is, it is the amount of water vapor that is present in the air. Okay, we all know what is air. Air is a mixture of gases, and also air contains water vapor and dust particles. Okay, so humidity is the term given to the amount of water vapor present in the air. Okay, and humidity differs according to our weather, according to places. Okay, so what we see, generally the northeastern region of India has higher humidity than compared to Rajasthan. Okay, so humidity differs from place to place, weather to weather, climate to climate. Okay, so it is simply the amount of water present in the air. So what generally we see, that the rate of evaporation increases when humidity is low. Okay, so what it means, if the amount of water vapor in the air is less, then the rate of evaporation increases. Okay, so why is so? So let us consider that here water, okay, water is evaporating. Okay, so when water will evaporate, so this liquid water is changing into water vapor. Okay, simple. So this water, when water is evaporating, it is surrounded by air. Yes, so the air, okay, air always has a definite amount of water vapor. Okay, and it is a capacity that, suppose water can hold up to only a fixed amount of water. Okay, okay, so after that it cannot hold more amount of water vapor in it. That is, it has a capacity, it has a definite capacity that it can hold only a fixed amount of water vapor in it. Okay, clear? Suppose, for example, just consider that, suppose this air surrounding the water, this evaporating water, it has the capacity to hold 50 particles of water. Okay, so how much? We are just considering that 50 particles of water vapor, 50 particles of water vapor can be held by the air surrounding this. Okay, so just imagine if the air around this already contains 50 water vapor, 50 particles of water vapor, and when you are evaporating the water, what it is taking place. So the general process is that the liquid water is changing into water vapor. Okay, so that means you already had 50 water vapor, 50 particles of water vapor. Again, you are adding water vapor from the liquid through the process of evaporation. Okay, so if this air already contains a huge amount of water vapor, then if again you will evaporate, so this water vapor cannot go into the air because the air already contains the maximum amount of water vapor. Okay, so then what will happen? The evaporation will not take place because the air will not allow the water vapor to go into it. Okay, so when air will not allow the water vapor to go into it, what will happen? Evaporation process will stop eventually. So therefore, when this air surrounding the evaporating water will have less number of water vapor in it, okay, then what will happen? When the water will evaporate, this vapor can easily go into the air. Okay, so less number of water vapor in the air will help in evaporating quicker. Okay, that means the air has a fixed amount of capacity to hold water vapor in it. Okay, so if the water vapor in the air will be higher already, then again through the process of evaporation, what we are producing water vapor. Okay, so if the air already contains a huge amount of water vapor in it, so the producing or the new water vapor that will be produced, it cannot go into the air. Okay, because the air already contains the maximum amount of water vapor. Okay, so due to this, the evaporation process will become slow. So if the air do not contains or contains a very little amount of water vapor, then what will happen? The water vapor that you process that you are producing through evaporation, that will easily go into the air. Okay, and when the water vapor will easily go into the air, then more amount of particles of water can evaporate. Okay, so due to this, the rate of evaporation increases when humidity is low, that is the amount of water vapor in the air is low. Okay, the next factor is wind speed. Okay, so generally we observe that when on a windy day, our wet clothes, okay, so the clothes that we wash, we keep it outside so that it can dry. Okay, so what happens on a windy day, we generally see that our clothes dry quicker. Okay, so why on a windy days our clothes dry quicker? Because the water that is present on our wet clothes, they evaporate faster on a windy day. And why it is so? So from this only you can know that the rate of evaporation increases with increasing wind speed. So when you windy day, the wind speed is higher, so that the evaporation increases. Okay, the rate of evaporation increases. Okay, so due to this, the water on our wet clothes it evaporates quickly, and our clothes dry quickly. So what happens? Suppose the wind is blowing from this direction. Okay, so now if the wind speed will be higher, then what will happen? Evaporation will occur generally. That evaporation is occurring, and the water is converting into water vapor. So what happens? This water vapor will be present surrounding this. Okay, so the water vapor that is newly being produced, it will also be present here. Yes. So if more number of water vapor will be present surrounding the water vessel, so what will happen? The amount of water vapor in the air will increase. That is, humidity will increase. So if wind speed will be higher, so what it can do? It can blow away all this. Okay. So what it can do? It can blow the water vapor to a far off place. Okay, to a greater distance. So once this water vapor will move from this side, so the air completely surrounding the water vessel, it is near to the water vessel, will have less amount of water vapor. Okay, so that means humidity around the water vessel will be low. Okay, so when the humidity around the water vessel will be low, evaporation will occur faster. Okay, so that means the wind, it helps to take away or move the water vapor surrounding the vessel. Okay, when evaporation is occurring. Okay, so once the water vapor moves, so this place will now have less water vapor in the air. So now the water vapor that is newly produced due to evaporation can easily move into the air. Okay, so that is the work of wind is to move away the water vapor that will be produced. Okay, so since water vapor will be moved away, so the air surrounding the vessel, from where a vessel or the surrounding the water where evaporation is occurring will be less, and due to this evaporation will be faster. Okay, so these are the 4 factors affecting evaporation. Okay, so now with evaporation we see a very interesting phenomenon, that is due to evaporation we see that cooling occur. Okay, so why cooling occur we will be seeing now. Okay, so now we are looking at cooling effect of evaporation. Okay, so it is little bit awkward, right? Little bit awkward, little bit in general terms we say ulta ulta. Okay, so what we have just now seen that evaporation takes place when temperature increases. Okay, so if evaporation takes place at a higher speed than when temperature increases, if temperature increase, then how evaporation will cause cooling? Okay, so these are two complete opposite things. Yes, so it is confusing, right? So now I will try to make you understand why cooling occurs during evaporation. Okay, so what we know that evaporation is a phenomenon that is related to the particles at the surface of a liquid. So here I am drawing with 2 different colors to show you different layers. Okay, different layers. We are considering, suppose consider 3 different layers. So the first blue particles that are drawn in blue color, so let us consider them to be the particles at the surface. Okay, so these are particles at the surface. Clear? So now evaporation will occur for this particle. Yes, so when this particle, for this particle to evaporate, okay, if these particles has to evaporate, so what they need higher energy. Okay, so only when the particles at the surface will have higher energy, then the force of attraction between the particles, only then the particles of liquid can evaporate. Okay, so that is a clear rule for evaporation. Yes, that the particles need to have higher energy than the force of attraction between the particles of the liquid. Yes, so how do we get higher energy? One is that they already have higher energy than the particles below the surface. Yes, we know that particles at the surface of a liquid generally have higher energy than the particles below the surface of a liquid. Yes, but the energy that they contains, it may not be sufficient to evaporate. Okay, so what they will do, they need some extra energy in the form of heat. We already know that heat is a form of energy. Yes, we know this, we already know this. Yes, heat is a form of energy. Okay, so what these particles will do, they need some extra energy and they will take it in the form of heat. Okay, so what they will do, they will take energy from the particles below the surface. Okay, so the particles at the surface, they will draw energy in the form of heat, okay, from the particles below the surface. Okay, and then they will have higher energy than the force of attraction and they will evaporate. Okay, so they will evaporate. So now what happens, the first layer of the particles has evaporated and is gone. Okay, so the first layer of the particles that evaporated into gas. Okay, so the first layer of the particles has evaporated into the gas. Means water vapor. Okay, clear? Now this is second layer. Okay, so this is second layer. So now what happens? Now once the top layer, that the particles at the surface initially has evaporated, now the surface is, the new surface is this one. Yes, this red particles is the new surface. Okay, because the particles that were present above them, they are already evaporated. So now at the topmost layer, since the particles above them, they have already evaporated. So now at the top, these particles exist. Okay, so now these particles will have higher energy than this. Okay, and these particles will also try to evaporate, because now these particles are at the surface and they will try to evaporate. So for these particles to evaporate, they again need higher energy. So they will also draw energy from the particles below them. Okay, so they will draw energy in the form of heat from the particles below them. Okay, and they will also evaporate. Okay, so now what happens, since the particles at the surface, they are gaining energy from the particles below them. Okay, so from the particles below them, so now what will happen, the particles that are actually present on the below. Okay, because the particles at the surface will be always less than the number of particles below the surface. Yes. So maximum particles are will be present below the surface. Yes. In every case, what we see that the number of particles will be higher below the surface. Okay. Than the number of particles at the surface. Okay. So since these particles are providing energy in the form of heat to the particles at the surface, so these particles are losing energy. Yes, because they are giving energy to other particles. Okay, so the particles at the top, to the particles at the top, they are giving their energy. So they are giving their energy in the form of heat. Okay, so what will happen? These particles at the bottom or below the surface, they will lose energy. They will lose heat. Yes. So when they will lose it, okay. So if you are finding difficult to understand in English, now I will repeat it in Assamese. That is, কি হৈছে তলৰ পাৰ্টিকলছ গিটাই হিটখিনি ওপৰৰ পাৰ্টিকলছখিনি দি আছে যিখিনি সাৰফেসত আছে ওকে সাৰফেসত থকা পাৰ্টিকলছখিনি হিটখিনি দি আছে তলৰ পাৰ্টিকলছ গিটাই ওকে সো যদি তলৰ পাৰ্টিকলছে হিট দি থাকে সাৰফেসত থকা পাৰ্টিকলছ গিটা তো তলৰ পাৰ্টিকলছখিনি হিটটো কমি যাব না নাই মানে টেম্পাৰেচাৰটো কমি যাব না নাই yes so the particles below the surface they will have less temperature okay so when their temperature will increase okay that means what they are losing heat and they are losing heat means what this portion of the particles they will cool yes so what will happen a small amount of particles has evaporated okay because at the surface we always have small amount of particles okay that means small number of particles they will evaporate but higher number of particles they will lose their heat okay lose their energy in the form of heat and due to this number of particles these many particles will cool down okay so their energy will decrease that is they will lose heat and their temperature will decrease and they will cool down so as a whole what we will see that the temperature of the water that has fallen okay that means the water that was initially suppose its temperature was high okay so their temperature will decrease okay and only a small number of particles will evaporate because the number of particles at the surface is very less okay so due to this evaporation causes cooling that is the particles at the surface they will take energy in the form of heat from the particles present below them okay due to which the temperature of the particles below the surface will decrease and due to this cooling occurs okay so this is the cooling effect of evaporation okay so next we will be looking at some examples of cooling effect of evaporation that is given in a book the first is acetone okay so this is presenting according to your book the example is given for nail polish remover okay and here acetone is present clear so what we are according to the book the example is given that if you are taking some amount of acetone so this is the chemical formula of acetone okay CH3COCH3 I think this you do not require but if you want to know so this is the chemical formula of acetone okay CH3COCH3 so let us consider this as our hand okay and here we are taking some acetone okay so what you will see that as soon as you put acetone in your hand this will evaporate very fast okay so this evaporates very fast okay and you will feel that your hand is now you will feel some coldness in your hand that is your hand the portion of your hand where you have put acetone so that portion will become colder okay so now why it is occurring because this acetone so that it can evaporate it needs energy okay and from where it will get energy it will gain energy from your hand okay so our human body has some temperature yes fixed temperature okay so what this acetone will do acetone will get the heat okay it will absorb the heat from our hand and it will evaporate okay so since heat will be absorbed from our hand that is our hands the portion of our hand where acetone will be present so acetone will take energy from that portion of our hand okay and due to this the temperature of that portion of our hand will decrease okay and we will feel some coldness in our hand okay so this is due to this we generally feel cool when we put acetone in our hand so this is the first example so next example every discussion is given about why we use photon procession somehow so what happens our body okay our body has a fixed temperature okay so during summer what happens the temperature around us that is around surrounding it increases okay so when temperature increases our body always tries to bring the temperature of our body to maintain the temperature of our body. Okay, so what happens when the temperature of the surrounding increases, our body itself decreases our body temperature, okay, and tries to keep us cool. Okay, so how it does? It does by using sweat. Okay, so what is sweat? Sweat is generally liquid. Okay, liquid, and it maximum amount and major portion of the sweat contains water. Okay, so what happens when we sweat? The water on our body, it comes to the surface of the body. Okay, so let us consider this is the surface of our body, and water from inside our body, it will come to the surface. Okay, it will come to the surface, and from the surface, what it can do? It can evaporate easily. Okay, since the water droplets or the water particle in the form of sweat, it comes to the surface and it can evaporate easily. Okay, so once it will evaporate, so for this water to evaporate, it needs what? For the water to convert into liquid, what we need? We have seen the latent heat of vaporization. So what is latent heat of vaporization? It is the heat required to change a liquid into vapor or gaseous state. Okay, so for this water particle in the sweat, it also has a fixed heat of vaporization. Okay, and what is heat of vaporization? That is a fixed amount of energy is required to convert into the vapor state. Okay, so from where it will get the energy? It will absorb heat from our body surface. Okay, so once the water out in the sweat will absorb heat from our body surface, the temperature of our body surface will go down. Okay, and our body will feel cooler. Okay, so due to this, on summer when we sweat, our body becomes cooler. Okay, so before sweating we feel very hot. Okay, so warm, we feel a warmness in our body, but as soon as our sweating starts, our body temperature decreases, and this is due to the evaporation of the sweat. Okay, and why use cotton clothes? Because these cotton clothes, so here we have clothes. Okay, so what will happen? If it is cotton clothes, then this cotton clothes can easily absorb the sweat. Okay, it can easily absorb the sweat. It can easily absorb, cotton can easily absorb liquid. Okay, like water. So what will happen? It will easily absorb the sweat, and it will bring the sweat to the surface of the cotton clothes. Okay, so from the body it will bring to the surface of the cotton clothes. Okay, so here there will be air. Okay, so since it will be, the water will come to the surface of the clothes, then from here it can easily evaporate. Okay, but if clothes will be present here and our body surface is here, and if the sweat will be present here, okay, and if it is not allowed to go to the surface, then it cannot evaporate and our body temperature will not decrease. Due to this, cotton will absorb the sweat, and it will bring the sweat particles to the surface. Okay, from where the sweat can easily evaporate, and as soon as these particles will evaporate, new sweat particles from the surface, it will be again absorbed, and from here again it can evaporate. Okay, so due to this, that cotton will easily absorb the sweat and bring it to the surface, and then the sweat can easily evaporate, and when the sweat will evaporate, it will bring our body temperature down. Okay, and we will feel cooler. Okay, so due to this, we use cotton clothes on summer, and it is an example of cooling effect of evaporation. Okay, an example of condensation is given in your book, that where it is discussed, and how it is discussed we will be looking at here now. Okay, so suppose this is a water bottle that you have allowed to remain in the refrigerator. Okay, so what, this is a water bottle containing very cold water, okay, or even ice. Okay, so what happens, the temperature of this bottle is very less. This bottle is very cold. Okay, so what we see, generally we see that after we bring it out of the freeze, some water droplets begins to form at the surface of the bottle. Okay, so when we touch the surface of the bottle, we feel that water is present on the surface of the water bottle. Okay, so from where does this water comes? Okay, so from where does this water come? So what do we see, the air around us? Okay, it has water vapor. Okay, these red dots are water vapor. Okay, so we already know that the particles of gases have higher energy than the particles of liquid, and the particles of liquid has higher energy than the particles of solid. Yes or no? Yes, because when liquid evaporates, the particles need to gain higher energy so that it can be converted into gaseous state. Okay, so that means the gaseous state, the particles in the gaseous states have higher energy than that of liquid. Okay, So particles of gas have higher energy at gaseous state, that is water vapor will have higher energy than water. Okay, so as soon as this particle will strike the surface of the water bottle, okay, so what happens, the water bottle, the temperature of water bottle is very low, that is water bottle is cold, okay, very cold, okay, and these are higher energy, that means these are the particles of water vapor have higher energy. Okay, so as soon as they will strike here, okay, so what will happen, that energy in the form of heat will move from the particle to the bottle. Okay, so we know that heat always moves from hotter bodies to colder bodies. Okay, so in this case the water vapor are the hotter bodies, okay, because they have higher energy. Yes, so as soon as they strike the colder surface of the water bottle, what will happen, energy will transfer from the particles of the water vapor to the surface of the bottle. Okay, so as soon as the energy of the water vapor will decrease, so what will happen, they will decrease to such an extent that the water vapor will condense. Okay, condense into, that is they will change into liquid. That is, we have learned earlier that to change gaseous state into liquid, we can decrease the temperature. Okay, so in this case what will happen, the water vapor, the energy of the water vapor, it will move to the colder body, that is the surface of the water bottle. Okay, so as soon as the energy will be transferred from these water vapor particles to the surface of the bottle, the energy of the particle will decrease. Okay, and as soon as the energy of the water vapor will decrease, it will change into liquid water. Okay, so due to this, the water droplets appear on the surface of the bottle. Okay, and as this as one by one the water vapor particles will change into liquid, okay, we will find more and more of water droplets are being formed. Okay, so this only takes place because the particles of water vapor loses its energy and its temperature decreases, and due to this water droplets are formed. Okay, so by this I think this chapter is finished. Okay, but one more thing, before finishing this chapter, I want to give you some more information, that is generate the differences between vaporization and evaporation. Okay, so I will give you here somewhere here the differences between the I will be giving you here the differences between vaporization and evaporation. Okay, so I think 4 or 5 differences will be present, so you can have a look at them and you can take a note of them. Okay, and I have, I think, already mentioned here that if possible, please subscribe my channel so that you can get some additional videos regarding your syllabus or discussion about question answer that has been already asked in different level in different schools or in some competitive exams. Okay, so I will be discussing such questions also. So due to this, I ask you to subscribe my channel. Okay, if you want, you can subscribe my channel. Okay, so thank you.